Good day everyone. Welcome to SKY Tutor. Today we're looking at mathematical induction. Now, mathematical induction is one of the ways of proving in mathematics in such a way that when we have a statement P of n, where this small n belongs to a particular set. Let's say it belongs to what? N, the set of natural numbers or the set of positive integers. So if we want to prove a statement, whether it is true by induction, it means if the first value of this small n in this set, if it is true, the next value should be true as well. So for this set, the element there is 1, 2, 3, because that was n is the set of natural numbers, with our counting numbers. So if this statement should be true for the first value of this n, so it means it should be true for the next value. So that is how to prove by induction. So we want to consider that question there. The first question, we have to show that the summation of this is equal to that. And what we have here by expression is actually what represents the sum of the first n term of an AP. And we are told that what is equal to this. But what we have here, we have it to be a function of n because it is expressed in terms of n. A and b there, they are constant. So if I want to establish this by induction, I will have to let that statement be equal to p of n. If the statement is p of n, so we have p of n to be a plus d plus a plus 2d plus dot 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 plus a plus n negative 1 times d, and is equal to n upon 2 into bracket 2a plus n negative 1 times d. So if we consider if our n is an element of natural number, because it is given there that n belongs to the set of natural number, it means n will be 1, will be 2, 3, like that. So I want to consider when n is equal to 1 to k and k plus 1. So what we'll have, when we put n to be 1 into this statement, if I consider p of n being equal to this, so p of 1, if n is 1, I'm going to be able to be equal to 1 upon 2 into bracket 2a plus 1 minus 1 times d. For this one, we give 0. So everything here, we give 0. So we are left with 2a in this bracket upon 2. So we have it to be a. So our p of 1 actually represents the first term, like the sum of the first term, and that one will be what? This. So that shows that what? The statement is true for this when n equals 1. So let's check whether the statement will be true for the next value of n, which is what? N equals 2. So if I put n to be 2 into this, I have it to be 2 upon 2 into bracket 2a plus 2 negative 1 times d. This we cancel this. So we have this one to be 1 times d, that is d. So we are going to have 2a plus d. So let's check whether this one is true using this series. Because p of 2 simply means the sum of the first two terms, which is this and this. So if I consider the first term plus the second term, a plus d, this plus will give 2a plus d. So that should have what it is true. This one is also true. So let's go look at when n is equal to k. When n is equal to k, we are going to have p of k. We can write down the series for that using this. It's going to be a plus d plus this one plus dot 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 plus this. But a term before this is a plus n negative 2 times d. So if I want to write the equivalent form of this term, the second to the last of this for this one, I will just have to change n to k. So it's going to be a plus k negative 2 times d. And the last term, which is this one, we just replace this n to be k. So it's going to be a plus k negative 1 times d. And it's equal to, so for this one, it's going to be k upon 2 into bracket 2a plus k negative 1 times d. So we will assume that what the statement is true for this. So if the statement is true for this, it should be true for the next value of n, which is going to be k plus 1. Is that what we now establish that what is actually what true? So if I have n to be k plus 1, the series is going to be a plus b plus dot 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 plus. So we can use the what? The term in this to get the term of this. What we just have to put in mind is that when we see k for this one, but for this one, we are going to replace the k of this one in the term with what? K plus 1. So for this now, the term that will correspond to this for this is going to be a plus. This k will be replaced with k plus 1. It should now be k plus 1 negative 2, which is k negative 1 times d. So that will be the second to the last term. And the last term will be a plus. This one will now be k plus 1 negative 1. That is k times d. So is equal to k plus 1 upon 2 into bracket 2a. If you put this one to be k plus 1, it should be k plus 1 negative 1. That is what? K times this d. We have for this. So if I want to establish that this one is actually true, I will have to consider this with this or series. So p of k plus 1 is equal to this to this. But from here to here, simply represent our p of k. So we can put that as p of k plus this last term. I repeat, from here to here, represent the series for p of k. So we can replace that with p of k plus the last term, a plus kd. But our p of k is having this value. So when we use that value to replace, we have k upon 2 into bracket 2a plus k negative 1 times d plus a plus kd. So when we simplify, we are going to have 2ak plus k into bracket k negative 1 times d plus 2a plus 2kd. Everything divided by 2. So it's equal to, for these two, we can bring them together. We are going to have 2a, because 2a is common, is a common factor to the 2. When 2a is out, I'm going to have k plus 1. And for this and this, I have kd to be the common factor. If kd is out, I'm going to have here k negative 1 to be left, and here I'm going to have 2 upon 2. So it's equal to 2a into bracket k plus 1 plus kd. For this one, negative 1 plus 2 will give k plus 1. Negative 1 plus 2 is plus 1. So what we have here will be k plus 1 upon 2. So this one is now equal to 2a. Like for these two terms, k plus 1 is common. When k plus 1 is factorized out, here we are going to have 2a plus, and here we are going to have k plus kd to be left there upon 2. And when we look at this very well, it's the same thing as the formula we have for the sum for p of k plus 1, which is this. That is what we want to establish, QED. Since, so we now conclude that since the statement which is p of n, if it is true for n, if it is true for n equal 1 to dot 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 k and k plus 1, it implies that it will be true for all x an element of n. For the second question, we have summation r equal 1 to n of r into bracket r plus 2, and we are asked to show that it is equal to this. That is, this series is equal to what? This. That is, this formula satisfies the series. So this series, what it actually means is that if we want to write it out in the raw form, so when we first put r equal 1 into this, we are going to have 1 into bracket 1 plus 2, and that will give us 3. So the first term here is 3, and the next term, if we want to get the second term, it's going to be r equal 2. So it's going to be 2 into bracket 2 plus 2, and that will give us 8. So we have 8 to be the next term. The next term after this, if we want to get that, r will be 3. So if r is 3, we have 3 into bracket 3 plus 2, and we have 3 times 5, that is 15. So the next time is 15 plus dot dot dot. So before getting to when r equal n, we are going to have r to be equal to n minus 1 before that. So when we put r equal n minus 1 into this, we are going to have n negative 1. If r is n minus 1 here, n minus 1 plus 2 is going to give n plus 1. And for the last term, it means r will be equal to n. So if we put r to be n here, we have n into bracket n plus 2. So it's going to be equal to 1 over 6, n into bracket n plus 1 into bracket 2n plus 7. Meaning this one, it simply means from here to here. So if you want to establish this by induction, whether this formula for the series is actually true or not. So we know that that small n belong to this set, a set of natural number, which is our counting number. That simply means our n will be 1, 2, 3, comma, dot, dot, dot. And if we assume that we have a natural number k, so we also consider what? K plus 1. So if we put the first value as 4, we need to first assume that this is a statement, because we have it is a mathematical statement anyway. So we have the intent of n. So if I assume this statement to be phi of n, so if this statement is phi of n, I'm going to have phi of n such that 3 plus 8 plus 15 plus dot 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 plus n into bracket n plus 2 equal 1 over 6 n into bracket n plus 1 into bracket 2n plus 7. So if I want to establish whether this formula is true for the series, when I put n to be 1 into this, I'm going to have it to be 1 over 6, 1 into bracket 1 plus 1, 2. 2 times 1 is 2 plus 7, that is 9. So this times this, everything here gives 18 divided by 6, and that is what? 3. So if we want to check whether this is true, we consider what? This series. Because phi of 1 simply means what? The sum of the first term. And that one simply means what? The first term. And the first term in this is 3. So that means it is what? True for this. So if we check for the next value of n, we have n to be 2. So we'll put that we have 1 over 6 into bracket 2, 2 plus 1, 3, 2 times 2, 4 plus 7, that is 11. So yeah, this one is what? 6 divided by this, so we left with 11. So let's check whether this one too is true or not. Because phi of 2 simply means the sum of the first two terms. So the sum of the first two terms in that series is 3 plus 8, which is 11. That means it is also what? True. So let us move to what? When n is equal to k. So if I move to when n equal to k, I can write down the series for this. It's going to be 3 plus 8 plus 15 plus dot 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 plus, for the term before this, which is this one, but we know that our n will be putting as k. So we have k negative 1, k plus 1, and we have plus k into bracket k plus 2. So the formula is going to be 1 over 6 for that series, k into bracket k plus 1 into bracket 2k plus 7. So for this one, we assume that the statement is true. So if we want to establish if the statement is true for this, it should be true for the next value of n, which is going to be k plus 1. So if we want to establish that, let us first put down the series. Phi of when n equals k plus 1, we have k plus 1. So the series is going to be 3 plus 8 plus dot dot dot. So we can use this one to get this. What we just need to do is that anywhere we find k for this one we replace the k with k plus 1. So I have k here. If I put as k plus 1, it will be k plus 1 negative 1, that is k. So when I put k plus 1 for this, I have k plus 1 plus 1, that is k plus 2. And for this one, I'm going to have k plus 1. So k plus 1 plus 2, that is k plus 3. So it's going to be equal to 1 over 6, k plus 1. So this k will be replaced with k plus 1. That is k plus 1 plus 1. That is k plus 2. And times. So when you put k plus 1 here, you have 2k. 2k plus 2 plus 7. That is plus 9. That is plus 9. So this is what we are going to have to be the formula for the series of this. So since we assume that when n equals k, the statement is true. So for this one, if it is true for n equal k, it should be true for n equal k plus 1. So let us establish this now. So from here actually denotes, represent our phi of k. So when I replace from here to here with phi of k, just to prove this one, because I want to consider this being equal to this series alone, to establish this one that it is correct. So our phi of k plus 1 is equal to, from here to here, simply means phi of k plus this one, k plus 1 into bracket k plus 3. But this phi of k has its own formula, which is this one, 1 over 6 into bracket k plus 1 into bracket k plus 2 into bracket 2k plus, the formula for phi of k plus 1 is this. That is k into bracket k plus 1 into bracket 2k plus 7 plus this one, k plus 1 times k plus 3. So let's simplify this and see, maybe it's going to give us this answer. So it's equal to, looking at this and this, something is common, that is k plus 1. If the k plus 1 is factorized out, k plus 1, and also I want to bring 1/6 out. So if k plus 1 upon 6 is out, here I'm going to have k times 2k plus 7 left here, but here we are going to have 6 because this one didn't have over 6. So the 6 we need to multiply this one. This one is out, so you have 6 times k plus 3. So equal k plus 1 upon 6. So in bracket here, when we expand, we have 2k squared plus 7k plus 6k plus 18. So is equal to k plus 1 upon 6. We have 2k squared, this plus this, plus 13k plus 18. So we need to factorize this. We have 2k squared plus 13k plus 18. It's factorizable by inspection. So the factor is actually 4k plus 9k. So we have 2k squared plus 4k plus 9k plus 18 is equal to this and this. The common factor is 2k into bracket k plus 2. And for this, the factor is 9 into bracket k plus 2. So we have 2k plus 9 into bracket k plus 2. So it means this is the same thing as this, factorized to this. So when I use this value to replace it in what we are solving, is going to be k plus 1 into bracket 2k plus 9 times k plus 2. Everything divided by 6. And when we look at this very well, it's the same thing as this. Because this one is here, this one is here. Likewise, so I can replace the position by putting this one here and this one here. So it's the same. So QED. Okay, now I want to look at the C part of the question, where we are asked to show that this statement is divisible by 9. So what we have the last statement, we have it in terms of n. So we have to represent it with something. So let's assume that that is what? Psi of n. Let the statement be psi of n. So psi of n is equal to 5 to the power of 2n plus 3n negative 1. So if we want to establish it, but our n belongs to the set of natural numbers. That means if n belongs to this set, it means n will be equal to 1, 2, dot. Let's say k is also what? A natural number and k plus 1. So if we put n to be 1 into this statement, let's see what it's going to give. So we have psi of 1 to be 5 to the power of 2 times 1, that is 2. So we have 5 to the power of 2 plus 3 times 1, we have 3 negative 1. So this one will give us 25. This plus 3 minus 1 is plus 2. So we have it to be what? 27. That is 25 plus 2, 27. And by observation, this 27 is same thing as 3 times 9, or we say 9 times 3. So that means this is actually what? True. Because since we have to be 9 times a number, that shows that it is true that 9 can divide this. That means that one is true. The statement is true for n equal 1. So when we put n to be equal to 2, let's see maybe it's going to be true. We have 5, 2 times 2, that is 4, plus 3 times 2, that is 6 negative 1. But 5 to the power of 4 is 625 plus 5. So we have this one to be what? 630. 630. And this one is the same thing as 9 times 60. So it is also true. So because we have it to be 9 times what? A number. So this one is as well what? True. So let us jump to what? When n equal what? K. If n is equal to k, we are going to have this one to be 5 to the power of 2k because our n now is not k. So it will be 5 to the power of 2k plus 3k negative 1. Now you observe a trend here. When we put n to be 1 and n equals to 2, we observe a trend that the result is what? 9 times a number, 9 times a number. So here too, if this one is going to be true, it's going to give 9 times a number. So we assume that the statement is true for n equal k, and this one too is going to give 9 times a number. So let me assume that it is 9 times x. I didn't know the x. I assume that the statement is true here also. So I can decide to make this one the subject. 5 to the power of 2k will be equal to, these two will transfer to this side. So I have 9x negative 3k plus 1. So I call this one equation dagger. Now when I consider the next value of n, because if the statement is true for one of the value, it should be true for the next value after that value we examine. So if we consider psi of k plus 1 is going to give 5 to the power of 2 into bracket k plus 1 plus 3 into bracket k plus 1 negative 1. So is this one we now want to establish that this one too will give 9 times the number. Because if you follow the word, the pattern we have for the rest, which is 9 times the number, that shows that what it is also divisible by 9. So what we have here, let's simplify this. What I have here is that 5 to the power of 2k, because this one will be 2k plus 2. And when we use the law of exponent, this one will split to 5 to the power of 2k times 5 to the power of 2. Plus, here we expand 3k plus 3 negative 1. So 5 to the power of 2 is 25. I have a value for this, and that value is this one from equation dagger. When we use that to replace this 5 to the power of 2k in this, we are going to have 9x negative 3k plus 1 plus 3k plus 3 minus 1 is plus 2. So it's equal to, here we have 25 times 9x minus this times this will give us 75k plus 25 plus 3k plus 2. So we have 25 times 9x. This and this is going to give us minus 72k, and this plus will give plus 27. So by observation, we see that these three words term has a common factor, and the common factor is 9. If 9 is out here, I'll be left with 25 times 7 is 25x. And here I'm going to have 8k, and here I'm going to have 3. So we are able to show that well, this one will give 9 times a number. So therefore, we can conclude that since the statement is true for n equal 1, 2, k and k plus 1, it's going to be true for all values of what? Of n, provided that n belongs to the set of natural numbers. So this is a tricky question, so we have to establish this. So in our next video, we are going to elaborate on how to solve this. So try and like our video, comment and try to share.